Hey guys, Sukanya here. Today we're going to be solving this integral, integration 0 to pi over 2 of root sine theta times cos to the power 5 theta d theta. And in order to solve this, we are going to be using u substitution, but I do want to emphasize that we first have to simplify this and then apply u substitution. What I'm thinking is that if I set u equal to sine theta, I know that du is equal to cos theta d theta. But unfortunately, we can't just apply this formula directly because we have a cos to the power 5 theta, not just a cos theta. So in order to make this expression have just a cos theta so that we can apply that du, I'm actually going to rewrite this expression as this. So essentially what I did, I just split cos to the power 5 theta into cos squared theta squared and then cos theta, exact same thing. And from there, I know that this is basically du as stated over there. And I know that sine theta, we already said that was u. And I'm going to rewrite this as, and I'm just going to add these bounds a little bit later because I want to first simplify the integral. But I see that we have this cos squared theta squared. And from over here, we don't have anything like cos squared theta squared. But what we do know, according to our trigonometric identities, is that we can write cos squared theta as 1 minus sine squared theta. And this actually works perfectly because we know that sine squared theta is just going to be u squared. So let's actually substitute that in. And now we have everything in terms of u. Once again, I'm going to add the bounds a little bit later. So let's actually just start to simplify this. Alright, so I simplified this part over here. Now I'm going to apply distributive property for each and every single one of these terms. Alright, now I'm going to add back the bounds, but once again, remember, in the original problem, these bounds were basically in terms of theta. But now, the whole entire integral is in terms of u, so we have to compensate for that. So as a result, what we're going to do, we're going to have when theta is equal to 0, and I'm picking this bound right over here, u has to be equal to sine 0 from over here, and sine 0 is just 0. Same thing for pi over 2. I'm going to substitute theta in for over here. Sine of pi over 2 is just 1. So our new bounds are going to be 0 to 1. Alright, so I integrated this. Now I'm going to substitute in 0 and 1, and that should be pretty easy for us. We have just 2 over 11 minus 4 over 7 plus 2/3, because if you put 0 in here, that is just going to result in 0. And taking the common denominator of 231, we should get 64 over 231 as our final answer.